Hey everybody. We've got a relatively quick video today, and I'm going to put this actually above kind of the other warm-up activity, even though it's not going to directly apply to that warm-up, just because there's some other things that you might benefit from before trying to do that Blukit or Blukit, which is a pretty fun activity. Hopefully you guys enjoy it. It's a lot about converting radians to degrees, degrees to radians, but they're just, I wanted to cover the top portion of this as well. So hopefully yesterday we did complete a unit circle and just some other components that are going to be beneficial to know on that unit circle is perhaps like the quadrants that we have. So you can see here that I've numbered the quadrants 1, 2, 3, and 4 in that little unit circle in the top right. And then I also just talked about, if you're looking for the sine of some angle, then really you're just looking for the y coordinate on the unit circle. If you're looking for cosine, then it's just the x coordinate. And then if you're looking for the tangent of some angle, some of them are relatively easy to come by, but on other occasions, you end up with a little bit of a tricky y divided by x, so your y coordinate divided by x coordinate. And, I say a little bit tricky because sometimes you'll get a stacked fraction, which we will navigate through in class, but you can also solve, by just multiplying by the reciprocal is generally the strategy that we go. So that little intro should hopefully help you kind of for that Tower of Doom activity warm-up that I have. But then today's lesson is also going to be relatively easy to come by just in terms of exploring. There's not too much kind of instruction. It's mostly just visualization. So here what we're going to be doing is completing a table for sine of x and trying to figure out that if I put this on a coordinate plane, what's it going to look like? Because I'm plugging in all of these values and then I'm able to get answers out of it. But, what does that look like if I actually try to graph it? And what's interesting about this, and you might be able to kind of see it from the unit circle, is that as I go around the unit circle, eventually I'm going to start either repeating values or, if I make a full rotation and I keep going around, to 400 degrees or something like that, then I end up almost repeating the entire graph. So it's definitely an interesting graph once we get there. So if I have to complete this table, it's very easy with a unit circle. And what I would say is you're probably going to be tempted to kind of state what the radicals are here, so maybe even like split this in two just so that on your first go we can just grab the radical values off of the unit circle and then convert them to decimals below, because obviously that's going to be a little bit easier for us to graph. So if I'm doing, looking through my unit circle, I can see that my y coordinate at 0 is this, and then I am just going by 45 degree increments here, and I'm just grabbing the y coordinates basically as I see them. So this is going to be here, okay. And some of these points I can plot straight off if I wanted to. But again, I'm going to try to get the decimal approximation. At least, all I need, it seems, is the square root of 2 divided by 2. So when I get that ends up equaling 0.707. And that's going to help me basically figure out the rest of this. Okay, and then we're going to start graphing this. So I've got 0, pi over 4 was 0.707, so I'm going to put it there, go up to 1, coming back down. 5 pi over 4 is negative 0.707, down to negative 1, and then heading back up. So we need to connect these points, and obviously, probably first and foremost, we definitely want to dismiss the straight line approach here. So we're going to end up drawing a graph that's going to come up, click, click, go all the way through. And if we miss some points, which I did, that's going to be all right. But then we get this, and as you can imagine, this is just going to, at this point, I'm kind of back at the starting point. So this is going to continuously repeat. So this is a periodic function. So every 2 pi, we're going to get all of these exact same values. And that makes sense on the unit circle because we're rotating once around. Then I would just run through the entire unit circle again. So the only kind of additional things that we're going to be doing here is, first you're going to take a look at cosine and do the exact same process. And then we're going to introduce these concepts here and answer some questions in regards to them. So it's important just to be able to identify with a periodic function, what is an amplitude. So an amplitude, just by looking at this graph, ends up being the distance between the midline and the maximum. Obviously it's probably going to be the same thing between the midline and the minimum, so that would also be an amplitude. And then a period is the distance between the x-coordinates that it takes to repeat itself. So as soon as I'm basically back to that starting point, and my pattern repeats. So it's not here, and I'll just highlight it real quick. Like, that distance wouldn't be a period because I haven't actually completed that full cycle yet. So I need to go this entire distance before I have that full back to where I started. Okay, and it doesn't matter where you measure that from, that period. We could go from here to here, and we're going to get that same exact x value. So once we have those x values, we could subtract the two, take the higher one, subtract the lower one, and that ends up telling us the period. But you're then going to complete midline, amplitude, and period of sine of x. Don't want to miss that question. I gave you some graphs to do that same thing. And then there is a Desmos exploration, which brings us back to, ideally this is ringing a bell with transformations because this is obviously pretty close. But we're specifically going to ask ourselves, between midline, amplitude, and period, what's changing and kind of by how much and things like that. All right, so that is kind of the skinny on today's lesson, and see y'all Monday.